Right then, so now let's move on to the next question in this case, which is going to be write a JavaScript function to check a given number is prime or not. So that is our next question. Write a JavaScript program to given number is prime or not. Okay, so let's see how to write a program for this. So first we need to understand what is prime number. Okay, so basically or not basically, mathematically a prime number is a natural number greater than 1 that has only only uh, that has only two distinct positive divisors, 1 and itself, which means a number which is divisible by itself and the number 1. Only these two numbers, only these two distinct devices, nothing else. Okay, for example, 2 is a prime number because its only devices are 1 and 2, right? So the numbers greater than 1 with more than 2 devices are called the composite number, like 4 divisible, like 4, which is divisible by 1, 2 and 4. So the number 1 is either prime number nor a composite number. For instance, if I say 5, so if I try to divide a number 5, and number 5 can be divided, which means you need to receive the remainder as a 0. So if you try to divide the number, you should get the remainder as a 0. So if you try to divide a number 5, you can divide it only by using 1, and you can divide it only by using 5. That's it. That's the number. That's the prime number. So for that, we need to write a logic. Okay. So what we can do, we can write a simple logic over here. Const is prime is equals to an arrow function. So that function is going to take the number as the input. Okay. So if that number is less than or equals to 1, then I just have to return false. Okay, so any number which is less than or equals to 1, it's not a prime number, so we are going to return a boolean value. Now we need to only loop up to the square root of the number for efficiency. Okay, so what we are going to do is, so for open it, let I equals to 2. So because we already mentioned it over here, right? So that's the reason we are starting it from 2. So I less than or equals to math dot square root. We're going to use the square root, open it. Okay, then we are going to send the number in it, I plus plus. Then I'm just going to open it here. If the number of modulo sign of I, which is equals to 0, then we just have to return false. So if it is divisible by I, it's not a prime number. Then we just need to return at the end over here as true. Okay. So what we are going to do is, I'm going to explain you what exactly this is. And okay, so here basically what we are having over here is, so we're having a function, right? So we know that we're having a function which is taking an input as a number, okay, over here. So over here in the first line, what we are doing, so any number which is less than or equals to 1, like 0, -1, 1, whatever it is, it's not a prime number, right? Then the prime numbers are greater than 1 and which is divisible by only by 1 and by themselves, right? So that is the reason we have written this condition over here. Then we jump into the loop part over here. So we are starting from I equals to 2 because we already checked the condition. All right. So I less than or equals to math dot square root of the number. So instead of checking all number up by number minus 1, we only check the number up by the square root. So why square root? If a number has a factor larger than its square root, its corresponding factor will be always smaller than the square root. Okay, so let me give you that over here in the explanation part so that you can understand over here. See, if a number have a factor larger than its square root, the corresponding factor will always be smaller than the square root. For example, let's take the value as 36. So for 36, the factors will always be uh, if you try to divide it into, like, what are the factors, like 2 and 18, right? That's the factors, because 18 into 2, like, it gives you the value as 36. Then we can say 3 into 12, that's the one more factor. And what is the other factor over here? 6 comma 6, that gives us the values, right? These are the factors for 36. So if you notice that you cross, like, you cross the value 6 once over here. So the factors are just repeats in a reverse order, right? So the factors will always repeats in the reverse order. So checking up to the square root of the number avoids the unnecessary work. So that's the reason we are checking up the square root of the number. Okay, so inside the loop, definitely we have to check this number of I, which is equals to 0. Okay, which means the modulus operator will always check for the reminders. So if the number of I, which is equals to 0, then the number is divisible by I. That means it has a factor other than 1 and itself, which is not a prime. Okay, so immediately we should return the value as false. Okay, for example, let's say if I'm sending the value as 9 inside, the loop will always start the value from 2. So when you try to divide a number by 2 percentage of 2 not equals to 0, then it continue. Otherwise, it will jump on to the next index, which in case the 3, 9 divided by 3, which equals to 0, which in case it's going to return the value as false. Okay, so that's how we are finally at the end, we are getting the value as returns true. So let me show you over here. So let's say if I'm supplying the value as s prime as 9. Okay, so here loop starts the values from I equals to 2, then I value will become as 2, then it will get inside the function, which is going to check the condition I modulus of 2, which is not equals to 0. Okay, so it is, of course it is not equals to 0, so that's why the condition will move on. The loop will, it will not get into the if condition, it will move on to the next index, which is going to be I is equals to 3. So 9 divided by 3, what happens? It is going to give you the values as which is equals to 0. So this point we need to return the value as false. Okay, so if the loop finishes without any finding any devices, which means that number is a prime number. Okay, it means no number divided that particular number unless it is a number, if the number is 1 or this it is the same number, then it's a prime number. Okay, so that's how we are figuring out that particular number. So let's say if I am sending the value as 7, is prime as 7. So what happens? I value will start from 2, it will get inside. So 7 divided by 2, which in case it's not equals to 0, then it goes for 3, I value will becomes 3. So 7 divided by 3, which in case it's not equals to 0, then the loop ends. Reason, because square root of 7 is 2.64, which the max value will become the I is equals to 2 only. Okay, so the no device, so the loop condition will becomes failed over here. okay, because the I value will start from here. So that's the reason. So the max value of square root of 7 is 2.64. Okay, so the maximum loop will can go up to 2 only, not more than that. So the divisor will never be found, so it returns the value as true at the end. Okay, so this is that particular logic which we used to figure it out, to find the square root using the square root method. There are different ways to figure out whether the number is even or not. They simply just use to divide that number. If the remainder is not equals to 0, then they simply say it is an even or odd. So but to figure it out whether it is a prime or not, you should be very careful. Okay, this is the code. You can use the single liner version for this, but that would be more confused, and it will confuse with everything. So it's better to stop right here, and I think this is more than enough for this question. All right, the explanation over here, you just need to be very careful why we are using the square root and all those stuff. All right, so let's move on to the next question.